Mr. Vishal Kapoor. He is the Managing Director, Mehno HCP Air Systems Private Limited, Chair ISHRE Technical Committee, Membership Chair IAQA India Chapter. He did his Mechanical Engineering from IIT Roorkee 1991, MBA from FMS Delhi 1993. He has 51 years of age and engaged with HVAC industry for last 25 years. Today, Mr. Kapoor will give us brief on ventilation and air cleaning. So delegates, let's welcome Mr. Vishal.
Very much, Krishna, for the kind introduction, and I look forward to having a good engaging hour and a half with all of you, my fellow panelists, as well as all the people listening in. So I'll be speaking for close to 10 minutes or duration, though that's a very, very short time to talk about ventilation and air cleaning, but obviously we'll need to listen to all subjects. So I'm going to start right away without taking more time. Now, we all know about the subject of ventilation and air cleaning. In the last year and a half, we've heard about it in media, we've heard about it everywhere, all around us, people talking about this. Though it's been there as an important subject for many, many years, but it's just come into more prominence at this point. Now, you've already had my predecessors talk about some of these facts, where we know that as an individual, as a human being, we could consume around a kg of food per day, around 2.5 liters of water, but up to 12 to 15,000 liters of air. But unfortunately, most of the times, we do not take the air we breathe very seriously, despite the fact that we spend 80-90% plus of our time indoors and not outdoors. And whatever you might do, however tight your building might be, 25% of outdoor pollutants can still get into an indoor space. So we need to be very, very conscious about the inbuilt environment, the spaces we are living in, whether it's our home, whether it's our office or a restaurant we're visiting, or a mall or a shop, wherever we are going, we need to be very conscious of the indoor environment. So I like to just start with what does an indoor environment basically mean? We normally just talk about indoor air quality, but when we look at indoor environment as a whole, it actually encompasses 4 aspects. Number 1 is thermal comfort. It broadly talks around the range of temperature, etc., and also humidity, which is also very prominent. We normally choose an air conditioner saying that as long as I'm feeling at 23 degrees, I'm feeling cold, I'm actually very good from an indoor environment point of view, but no. The second most important thing, if maybe also the most important thing, is the indoor air quality, as to the kind of air you're breathing with all the contaminants, etc. The other 2 aspects which affect our experience indoors are the lighting and acoustics. All these elements are very well covered in an IQ standard, which was launched by ISHRE and again was renewed in 2019. You can go to the ISHRE website and download this book to know more about the standard on indoor environment. I'm just trying to bring you on par with everything that we're going to be talking about today, not only in my session, but all the next 90 odd minutes. Now, if you need to improve the indoor air quality, we as engineers, as HVAC design engineers, we talk about various ways of doing it. Obviously, it starts with a good design, whether it's the right integrated building design, that means the position, the orientation, the intakes, the exhaust points. So how do we ensure that the building is designed in a very well manner? Then we talk about ventilation as one of the most important parameters to be able to ensure a good air quality, followed by air cleaning, filtration. I'm going to be talking a little bit more on the slides ahead. Distribution of air, because we need to ensure that the right air is reaching at every point and not just being left somewhere to flow on its own. We talk of pressurization, whether it's internal, external. We want to manage the moisture content inside, but that's a very, very, very big enemy of the indoor environment conditions. Source control, that means the kind of material we select indoors, whether it's for first-time construction, whether it's for maintenance of the space inside, whether we have commissioned the system in the right manner, whether we are operating it, whether we are maintaining it, and as per the new protocol, checking for the conditions of the system on a periodical manner. And finally, are we monitoring, are we measuring what we have? Few of my speakers after me are going to be addressing some of these facts so that we get more on level over there. Now, what is ventilation? It gets confused at times. People don't understand really what ventilation is. I'm keeping my PPT very, very, very basic so that it's easier to understand and grasp for all of you listening in. So we say ventilation is the process by which clean air, obviously normally we address it to outdoor air, is intentionally provided to a space, to an indoor space, and the stale air is removed. That means we are filling in fresh air and we're taking out the stale air from that space, very much like what we could do a bottle of water. We could do this either by natural means of air coming in through a window and flowing out through some other opening in the roof, in the wall, or whichever way, or we can do it by mechanical means. Why do we need ventilation? basically to provide oxygen for metabolism, and also very, very important to dilute the microbial pollutants, for example, carbon dioxide, which normally builds up with more and more occupancy inside a built space and can cause major damage to us, some short-term, some long-term, to our productivity, to our brain cognitive levels, and a lot of other factors. So we need to bring in outdoor air to keep on diluting the CO2 levels inside and increasing the oxygen levels inside. It is also used in maintaining good indoor air quality by diluting and removing other pollutants emitted within a space. For example, in these COVID times, the co-virus, which is riding with other particles or other droplets, because it is not known that it is an airborne virus, we need to bring in air from outside to continuously dilute and take those particles out. So this is primarily how we address ventilation. What are the ventilation techniques? Keeping it very simple. People confuse recirculation and ventilation. Yes, it is ventilation, but it is not outdoor ventilation. It's just recirculation-based ventilation. I'll talk a little bit about that. Natural ventilation, you're going to be hearing Dr. Yash speak about this aspect a little later. Mixed ventilation, you can see that in bold and blue because most of the applications in our country or globally are managed with mixed ventilation. And there's something of displacement ventilation, which is a fantastic technology, but very few and very limited applications. This is how we achieve ventilation in any inbuilt space. What is air circulation? Now, if you say that air circulation and ventilation, basically, it is used in buildings to provide thermal conditioning. Even a fan, even a ceiling fan for all practical purposes is air circulation, and it is surely giving us comfort. Recirculated air is usually cooled or heated and also at times filtered. For example, a high wall AC, which you could be having in the room you're sitting in right now, is also doing air circulation and is doing some extent of filtration, cleaning the air, because every air conditioning unit will have some or the other level of filter inside. However, since oxygen is not being replenished, metabolic pollutants are not being removed, recirculation should not be considered as contributing towards ventilation needed. It is basically ventilating the indoor space for thermal comfort and not for improving the air quality inside the space. How do we measure air ventilation? A lot of us here keep on hearing things like air changes and ACPH, ACH. Basically, it is a measure of the air volume added to or removed from a space in an hour divided by the volume of the space. Let's make it a little simpler. That means you say 2 air changes per hour, which basically means that twice in 1 hour, I am replacing the entire air of this room that I'm sitting in with outside air. So that is how we presume air changes per hour, and mostly ventilation globally is now being talked about in air changes per hour. But it is obviously calculated in the terms of air quantity, which could be CFM, cubic feet per minute, or liters per second, basically to understand how much ventilation is needed. And it then gets converted into an air change per hour. This is a very important thing for you to understand what this air change per hour means. I have just given an example in front of you. I won't spend too much time on this. So you calculate the volume of the room you are in, area by height. Then you check how much outdoor air I'm bringing in. And from there, you get this formula to calculate how many air changes am I doing per hour. Now, this is how we talk about ventilation rates globally. Any kind of an application, any kind of a technology used, whether it is natural or mechanical or mixed, this is how we calculate ventilation rate in a room. Now, when I have to calculate how much ventilation does this room need, this space need, what are the aspects we need to look at? There are charts, there are tables available in the HVAC data book that you can refer to understand for different kinds of applications, how to calculate the ventilation rate for that particular room. But broadly, it depends on the application of that room. Is it a restaurant? Is it a shop? Is it a gym? Is it an office? Is it a bedroom? Is it a classroom? Various kinds of applications or space. It also depends on the activity level of the occupants inside. Are you smoking? Are you drinking? Are you doing exercises in the gym? Are you sleeping? Are you studying? So what level of activity you are in, depending on that, you would need more or less of outdoor air. Occupancy in that space. How many people are going to occupy that particular space size? And obviously volume of that space. So these are the 4 main criteria around which we calculate how much of ventilation is needed. But at the very same time, a very important factor to consider is the ambient air quality and the temperature, humidity outside, because too much of ventilation is also going to affect that, because if the air outside is very polluted, very dirty, or it's very hot or humid or a combination, and you're trying to bring in more of outdoor air, it is obviously going to impact the space inside, both in terms of air quality or the thermal conditions. Then you will have to either treat the air or filter the air properly so that what we bring in does not cause us more harm than benefit it was supposed to do to us. Now, what is filtration and air cleaning? It is basically used to improve the indoor air quality, and very importantly, it sounds a little funny, and occasionally to enable a reduction in the rates of outdoor air ventilation, because even a filter basically is controlling, capturing, deactivating the contaminants inside a space. There are various technologies available today. And how do we choose? It basically depends on the type of contaminant that has to be removed. What are you removing? There are various kinds of contaminants. Is it a particulate matter? Is it a VOC? Is it a biological contaminant or a microbe or whatever it might be, depending on the kind of contaminant you want to remove and the principle of contaminant removal, you can select the kind of filter that you want to go in for. Some very, very basic kinds of filtrations. So when you look at the kind of contaminant, if it is RSPM, which is respirable particulate matter, you keep on hearing about this PM 2.5, PM10, PM1 particles. Basically, we normally use a mechanical filter or possibly at times electrostatic. Then, for example, we can use UVGI, which is very, very popular, become very popular recently, where we have microbial particles that we need to filter. We could have VOCs. So, or say, for example, a gas or an odor, you will use something like gas-based filters. Or you could even use a combination of these filters, depending on what you are treating. Don't just go blindly selecting the filter. There's no point overdoing it, because some of these filters can have some other adverse effects, whether contributing to health or even contributing to energy losses. So you, depending on what you're treating and how you want to treat it, you choose the kind of filter that you need to have. As I said, there are pros, there are cons of each type of filter. Where there's ozone generation, there are replacement costs, there are maintenance costs, energy goes up because there's a pressure drop across this filter when air has to be pumped in from suction to discharge. So you need to have more kilowatt of motors and fans to be able to take the air. And obviously, some will be less effective, less efficient, more efficient. So you need to be very conscious of choosing this. Where do we install these filters? The various points or a combination of these points. The first is the primary point of air supply, which could be the air handling unit or your indoor split AC. This could be mechanical filters, electronic filters, active filters like ionizers, etc. You need to 100% install filters in your outdoor air suction, because you need to filter out what you're bringing out in from outside. That air is very polluted. So you put mechanical or gas-based filters in the outdoor air suctions. We can put filters in duct. In duct could be either UVGI to control microbial contamination, or you could have mechanical filters also in duct types if needed. Or very popular now are standalone purifiers, which are typical air purifiers, which could be floor mounted, it could be ceiling suspended, ceiling mounted. These are standalone air purifiers, which are just recirculating, filtering, cleaning the air locally within the room. And you can have a combination of any of these ways of putting a filter in a comfort space. Mind you, I am just talking about very simple comfort applications. We're not getting into healthcare, or we're not getting into pharma kind of applications. Simple office, home, restaurant comfort applications. Now, there are guidelines available for selecting these filters. You can download this book, which is the Air Purifier Guidebook from the ISHRAE website, which talks about guidelines for selecting filters. There are various technologies mentioned over there on this column, and what substances can that technology remove from particulate matter, CO2, VOCs, other gases like NOx, ozone, aerosols, etc. And also at times it talks about possible, just to be careful, some side effects or issues that these technologies could or might have. So you can actually read more about this in the website, in this book, which you can download again from the ISHRAE.in website. Again, you want to know more about filters. It's a very, very interesting subject, very, very technical subject. You could go, there's a book called Fundamentals of Air Filters by ISHRAE. You could buy this book from the website, and it gets into more details about filtration. For example, kinds of filtration can be gravitational, adsorption, chemisorption, electrostatic, mechanical, etc. It gives you a lot of information for those who want to know more about filters and want to specialize in that field. You can go through this book. I'm just going to take you through the last 2 slides on some examples, some very, very basic drawings, and look at the top right of a screen. Top right of a screen is where you see a typical room where you have cassettes. This could be a restaurant, because cassettes are very common in restaurants, or it could be a shop or an office space. Top left is which you end up seeing in many places in our country, where the cassettes are installed and there is no outdoor air, there's no fresh air coming in there. It's actually a crime. You're actually going there to get sick. And now, how do we improve it? There are various ways, even whether it's a retrofit application where it's already existing or a new design, there are ways of bringing in outdoor air ventilation into these rooms. And you can see the various options in front of you over there. The top right is the extreme point, where we have a treated fresh air unit with filters installed over there, supplying fresh air, outdoor air, which is filtered and treated for temperature and humidity, so that it's comfortable 23 degrees air or being thrown into the space directly. On top of that, because in cassettes, we cannot increase the filtration levels, because we cannot do more filter in a cassette because of the pressure drop. There are standalone purifiers that can be installed in that space, which is doing 4 to 5 air changes per hour. That means 4 to 5 times air volume flowing through that purifier to clean the air and throwing it back into the room. So you have a combination of both ventilation and air cleaning happening in that particular picture. Let's look at what happens in a room which has a larger unit, like an air handling unit or a larger ducted unit. This could be an office space, this could be a large showroom where we have these units installed over there. Again, there are various ways of achieving outdoor air ventilation. You have the first drawing, which shows treated fresh air unit, which is supplying air directly into the occupied space. This is required more when you have multiple zones inside that office space. You have chambers and meeting rooms, so you need to have the fresh air reaching or outdoor air reaching more of those places. You use this application, or you can have the bottom right picture where you have the fresh air or the outdoor air is being supplied at the back of the air handling unit. I don't need to treat that air at times, because that air is being treated in that air handling unit, then being supplied inside. You are seeing a sign of a positive, negative. That means the space inside is positively pressurized. That means whenever the door opens, air leaks out rather than leaking in, so that the outdoor pollutants, dust, etc. are not entering this space. That is very important to control the indoor air quality. Again, one of the ways of achieving a mix of outdoor air ventilation as well as air cleaning happening inside that space, you can see the air handling unit has 2 levels of filters, which could be a MERV 7 and a MERV 13 installed in that air handling unit. You have an outdoor air fan through a filter, which is pushing in air into the air handling unit. And then within the space, we have installed some air purifiers to further recirculate, clean, and filter the air to ensure that the air you're breathing is as clean as possible. So the summary of my presentation would be that outdoor air ventilation is a must, absolute must for all applications. Anything, whether it's a chamber, it's your bedroom, it's your office, it's your clinic, any application, outdoor air ventilation is an absolutely must. Overdue of anything, whether it's ventilation or filtration, is not advisable. We suggest a combination of air cleaning and ventilation. That is the right balanced approach to achieve good indoor air quality. You just cannot keep on saying increase outdoor air to 6 air changes, 4 air changes. No, your system will not be able to manage it. Your conditions inside will deteriorate. It's bad for the health from many other aspects. So have a combination of outdoor air ventilation and the right amount of cleaning happening. Very important to look at how you're distributing air inside the space. It is not simply just throw in the air. No, it has to be properly supplied and extracted from that space. Monitor air quality, at the least monitor the CO2 levels inside the space. That is a very, very good indication of the ventilation levels in that room. If your CO2 is in control levels, is staying within 200, 300 ppm of the outdoor air CO2, means your space is well ventilated and your CO2 is in good control. So monitor your CO2 as continuously as possible. And finally, there is no replacement for source control. So first, you have to identify the source which is adding contaminants to your space. For example, even thermal screening of people entering a space is actually like a source control, because you're not letting someone who is COVID infected walk into your indoor space. But whether it's carpets, whether it is polishes, a lot of other material, most important is first get rid of that, then do the other aspects. So thank you very much. And I would just like to sign off with this phrase, which is there in front of you, that together all of us can and need to change our environment, and our future only then is safe. Thank you.